Hi, good morning everybody. My name is Chirag Nagpal and I'll be presenting deep Cox mixtures for survival regression. This is joint work with Steve Yudlowsky, Nigar Rostamzadeh, Catherine Heller at Google Brain. The Cox model is a popular approach to model right-centered survival data, but has some limitations. It makes a strong assumption of proportional hazards. While the Cox model is well calibrated on a population level, however, it might overfit to the majority demographics. This might lead to misestimation and poorer calibration on minority demographics. Here's an illustration on the popular support dataset for survival analysis. In the case of the support dataset, about 20% of the patients were minority non-white participants who had a different base survival rate as compared to the majority. The Cox model has a tendency to overfit to the survival characteristic of the majority. A natural way to model this divergence or discrepancy is to model such a survival problem using a fixed size k component mixture model. Our model consists of the input features x that pass through a MLP or a VAE in order to obtain rich nonlinear representations of the input data. These representations then interact with learned functions f and g that determine the component-specific hazard ratios and the mixture weights for each of the components respectively. For each of the mixtures, we estimate the base survival rates using the Breslow's estimator and interpolate them using splines. We average over each of the individual component survival estimates in order to obtain the individual level survival rate for a patient in the dataset. We experiment on several real-world survival analysis datasets of varying levels of sensory. We find that our proposed approach, deep Cox mixtures, has similar discriminative performance as compared to existing deep learning models for survival analysis. In terms of calibration, our model outperforms existing deep learning based survival analysis methods. We also evaluate the calibration of our model on the minority demographics and find a similar trend of our model being better calibrated. We further perform a qualitative analysis of our model by extracting learned clusters using the mixture model approach. We find that the model is able to capture clusters or latent subgroups that demonstrate non-proportional hazards, as is evidenced from the intersecting survival curves in this plot. I look forward to answering any questions at the poster. Thank you.